In this video, I'll be going over the section 7.5 day 1 notes. Today we're going to talk about properties of logarithms that will help us expand and condense logarithmic expressions. The first property that we're going to look at here is called the product property. And if you have the log base b of two terms that are being multiplied together, you can actually give them each their own logarithm and expand them using addition. So notice log base b of m plus log base b of n. This is very similar to your rules of exponents. So let's say I had 2 to the third times 2 to the fourth. Well, we know that according to the rules of exponents, if I multiply and the bases are the same, I can actually add those exponents together. It's not the exact same property or the exact same rule, but since logarithms and exponential expressions are inverses of each other, there are some parallels or some similarities that we can see in this rule. So it makes sense for the quotient property. If I have a quotient of two terms inside of a logarithm, I can split them up, giving them their own logarithm each, but then subtract the numbers. So if I had 2 to the 8th divided by 2 to the 3rd, I would subtract those exponents and get 2 to the 5th. So very similar property here. But probably the most important one is the power property. And the power property says that if you're taking the logarithm of a term that has a power already, since logarithms deal with powers themselves, you can use the power property and take that power and put it out front of the log as a coefficient. So move the power and it turns into a coefficient, which is a very powerful thing that we're going to use down the road. But we're just going to practice for these first few problems to expand. So you're looking for multiplication, you're looking for division, or for powers. That's it. So for problem number 1, that is 9 times x. So I'm going to write this as log base 4 of 9 plus log base 4 of x. That's the expansion. For problem number 2, I see both multiplication and I see a power on the x squared. So I have two properties here. So I'm going to start with log base 2 of 3 plus, but before I write log base 2 of x squared, I'm going to put a coefficient of 2 here to represent the power property. So I'm going to write log base 2 of x to finish this problem. So instead of writing an x squared here, I basically just took that square and I moved it out front using the power property. But you'll notice it just goes out front of this logarithm. It doesn't go out front of the whole expression because the power of 2 is just on the x. It wasn't on the 3. For number 3, you would just have log base 9 of x minus log base 9 of 5. And that's just the quotient property. For problem number 4, there are a couple different ways that you can write this, but you'll notice that the x has a power of 3. We have division, but then we also have two terms in the denominator. So I would start with 3 times the log of x. That's your numerator. Minus, because of division, log base 2. Now at this point you have a couple things that you can use as a final answer. Since the 2 and the y are together, if I put a set of parentheses around this log base 2, around this denominator, I could go ahead and put a plus sign here and then finish it with log of y. Or you can distribute that minus sign into both of those terms to get 3 times log of x minus log of 2 minus log of y. And so the reason why, if you drop the parentheses, that this has a negative exponent, a negative coefficient, so there's a negative sign here, it's because really that's a negative 1. So there's like a negative 1 right here, and as a property, I can use the power property to put that negative exponent back on here, and things that have negative exponents are in the denominator. So you either need to use parentheses if you want to keep that a plus, or distribute the minus sign. So that is going to take us to number 5, which I'm going to write down here because I'm going to run out of room. This would be log base 5 of 3 plus 2 times log base 5 of x, just minus log base 5 of 4. And number 6, just recall that anything that is taken the cube root of is also the same as raising it to the 1/3 power. So I can just use the power property here to get 1/3 times log base 4 of x. So those are all expansions, taking one logarithm and expanding it into multiple logarithms. I'm just going to go through and highlight my final answers, though this one would be acceptable as well. So let's go ahead and go to the next page. So the power property, the quotient property, and the product property are relisted at the top for you. And so now what we're going to do is we're going to condense it. So given multiple logarithms, we are going to try to convert it or condense it down to 1. So for problem number 1, I'm going to write log base 4 once. And then I'm going to write the next part, that's subtraction, so that changes back to division, and that would be 9 divided by 5. For problem number 2, I can take that 2 and put it back on as a power on x. So if I write log base 2, that would be 3 times, that's actually x squared. So 3x squared. For problem number 3, I write log base 9 once. I see a subtraction sign, so I'm going to write division automatically. The numerator should be x to the 3rd, and the denominator should be x to the 2nd. Those are like terms, so that actually would be log base 9 of just x. If those variables were not the same, if they did not have the same bases, then I couldn't do anything to get that final answer, and that's just fine. Problem number 4, I have log. Now this should be x squared, and this should be y to the 3rd. And those are just going to be multiplied together. X squared, y to the 3rd, just like this. Number 5, so I have log base 5. So this is going to be 2 to the 5th, x to the 2nd, y to the 3rd. And so that is the same thing as log base 5 of 32x to the 2nd, y to the 3rd. A couple more here. Number 6, log, fraction. In the numerator, it's just 5, but notice there's 2 subtraction signs here. Anything with a subtraction sign out front ends up in the denominator. So this is x to the 4th, y to the 6th. And the denominator. So be very careful on that. The y to the 6 should be in the denominator. Last but not least, number 7, log base 4. This should be 6 to the 3rd and then y to the 1/4, which I can change both of those. 6 to the 3rd is 216, and then 1/4 is the 4th root of y. And that right there is your video.